Hi, everybody. My name is Noelle CEO. I'm joined here with my colleagues, Jared Vaudry and Srivatan Ramanujan. And we are from the Pivotal Data Science team. And what this really wordy title of this slide deck really means is we're here to talk about data science. And specifically, not just data science that lives in PowerPoint presentations or just the fancy models that get all the attention, but really how do you deploy that at scale? How do you do it in a way that really brings it to just being fancy models to something that businesses, and specifically media, uses? And it's not something that is just limited to proprietary tools, but really there's an open source framework and a way that you can do this so that you can have repeatable models in an ecosystem that really brings all of the innovation and the promise of big data for media companies. So we're going to walk you through a few things. We're going to talk a little bit about what we think of data science in media specifically, what some of the best practices there are, some example use cases, and then again, how do you bring that to life? So we're going to talk a little bit about the applications that use those data science models, and ultimately the framework underlying all of that for both the data science and the application itself that are all, again, open source. A little bit about data science in media. I'm sure you've all heard the differences laid out about insight versus foresight versus hindsight. And table stakes is really trying to understand what happened, using the data to know what actually showed, what was the content that aired, who was your audience, how profitable was it really? So they're all questions that, again, everybody wants to establish as a baseline. And the questions that people then begin asking is, okay, now you know what happened, can you predict what will happen next? And this is something that's not new for any business, really. But what's interesting is a lot of how people do this today is based on intuition still. It's based on small amounts of data. And what we say is, like, let's disrupt how this goes and really think, rather than just saying, we think what will happen next, what can you really do about it? How can you optimize this? How do you make this better or work in the way that you want it to? And this is the key of where data science comes in. So using big data, using all of these insights that you can glean, you can ultimately change that experience and change what the end user sees. And really, once you start playing with that, that ultimately changes what will happen next. What do the thought leaders in this space have in common? Right, so when people think of who are the leaders, we think of folks like Netflix or Pandora or even YouTube. You know, what do they all have in common? You know, other than obviously coming from the digital media side, what is it that they're understanding, and how do they look at their data that makes them different? First and foremost, they have a large amount of structured and unstructured data. So when we think of structured data, you think of all the metadata that they're collecting, or you think about all of the performance metrics. But unstructured data comes from things like weblogs or video itself, raw video. They also have a deep understanding of who their audience is. We're in an age now where, rather than marketing or doing things for general and broad audiences, we can now say, show the right thing to the right person at the right time. We're in the age of customization. And in order to be able to do that, you have to know a lot about who your audience is and a lot about your individuals. And these companies are all well known for that. I'm sure you all have Netflix and you all get recommendations not only to you, but every person in your household. In addition to knowing who their end user is, in a B2C business, they actually also have a deep knowledge of their own products. And this seems intuitive, like of course they know what's in their portfolio, but how much quantitatively do they know? So you can imagine that folks like Pandora, it's not only who's the artist, who's the genre, but all of the things that they can detect about each and every song. What's the gender of the singer? What are all the instruments? How much percussion is there, instrument related or not? What is the distortion for many of the instruments? All of these things they have hundreds and thousands of things that they're gathering, not just from somebody who's sitting there marking all these things, but also in an unsupervised manner. For us, what really sets all of these businesses apart is that they have a data-driven culture. So not only are they sitting on a massive amount of data, they're doing something with it. They're able to say, we can make decisions about anything based on data, and we trust the data. It's not just about instinct, it's also about data. And what I said earlier about showing the right thing to the right person at the right time is that the user experience, what you see, is ultimately optimized by data science. Everything you see is not, again, has some data backing it up to say this is the right thing or this is the optimal thing. It's lots of experiments that ultimately culminate to the experience that you have. So one of the things that we always I mentioned earlier and we talk about constantly is data, right? Like all of these problems are served by not only including internal data sets, but getting as much data as possible into one place. So as a starting point for any framework or ecosystem is putting all the data in, getting as much data as you can. So typical internal data sources that you see in media companies are as follows: things about viewership, who is your audience, and then anything ultimately related to revenue. So they see things like, what was the advertisements, finance, what did we sell? And then they tend to augment this of, okay, this is our business, but who is our audience? So you see a lot of the same players in the space with external data sets that get bought over and over again. So audience demographics, what does the market say, lots of survey-based things. And we're saying, the power, put all those things in one place, of course, but where's the power? The power is by adding semi and unstructured data to this same data set. And again, I'm putting all of these things in one place. So you can imagine that clickstream analytics, right? This again, where you see the emergence of innovation from the digital media players, understanding every single action that people do and interact with content. Social media, which is its own emerging field, and we'll talk a little bit about use cases later. And then the content itself, right? Like how much do people actually use the things that they have in their portfolio and analyze all of that data to understand what they can control and not. So all of this data, and again, this is not a completely exhaustive list, right? But all of these, this is just examples of things that we're seeing that people put together. So where does data science really come into play for businesses? So one of the things that what gets all the press for data science is all the algorithms. But what we're saying really is that data science has impact across businesses because ultimately they can help answer various business questions. Some things that you may see from businesses, they'll say goals like, we need to increase revenue or we need to reduce cost. That's easier said than done. But when you break that down into more specific things, okay, for a media client, let's increase the demand or let's help build our brand equity. Or even further, okay, increasing demand, what we need to know is more, how do we increase our customer engagement? How do we make sure our customers stay more engaged with each of our products or have longer time spent on our websites, whatever? Or how do we ultimately optimize our ad spend? Are we spending our money in the right place? For reducing costs for a broadcast company, this could be increasing their production efficiency. So this is just a small example of all of the different sort of business requirements or business questions that we get. And our point is that we're saying there's a data science opportunity for all of those things, right? So if you have all of that data in one place, in this really great blended data set, you can have a framework where you can start answering all these questions with data science for each of those. So problems that you hear like understanding affinity analysis or doing social media analytics or doing demand forecasting, all of those things can be served by data science. I want to walk you through a specific use case. So one of the things we worked on recently was trying to predict ratings. Right? For a specific show or shows, we can say, we want to understand, this is common use case, let's increase our ratings across various user demographics. So people who look, watch. And the question is how? How do we do this? So again, typically the way that this is answered is by taking things like metadata for the shows and looking at the ratings that come out every week and using that. But we said, what's the big data approach to this? What's a more interesting data science approach to this? So let's add as much unstructured data as we can. Let's put some transcripts on there. Let's put some more metadata. And of course, this is something that could be extensible to other forms of data as well. The model itself that we built was actually using machine learning to identify what are the different impacts of the production decisions on this viewership. So the question isn't just, hey, can we figure out what the number of commercials or what the number of any specific thing that we put in a show affects, but can we take a step back and see of all of the things that we put into a show, what is the actual most impactful and what's the most impactful for each individual audience. And with that, what I'd like to do is turn this over to Jared, who will tell you a little bit more about this model and how you can take that model from something that just lives purely in a kind of scientific way into actions for the business.
Great, thanks, Noelle. Yeah, so the title here kind of sums it up, right? Often within data scientists, we get stuck into the kind of mathematics, machine learning behind it, statistics. We build a bunch of really cool, powerful solutions, right? And then we need to really create value from those, right? And so typically what happens is we have the model, we drive some insights out of those, but really what makes a good insight, right, is that it drives action, right? And that action creates value for the stakeholders. Let's walk through a little bit about how that goes about. So we start off with a business question, right? And that might be, what makes a viewer tune in or out, right? Thinking of the ratings example. Next, we'll send some data scientists like Watson and Noelle in there, come up with a cool model, and we might identify an insight that says, on-screen arguments make viewers tune out, right? And so that's an insight there. But how do we now take that and create an action that creates value from it, right? And traditionally, how we've seen this happen is through one of these channels here. You find something cool out, hey, I've got an insight here, on-screen arguments are making viewers tune out, quickly type that into an email and send it over to my boss or direct report, who then also thinks that's a great insight, but it tends to die there, right? We also see that happen a lot with reports, presentations, right? You often sit in a presentation and say, wow, that's great insight. You walk out of the room and, where does that actually go? Where do we create action from that, right? We also see this with static dashboards. Some people put together amazing dashboards, all kinds of visualizations, if I can get that word out. But in there, right, it doesn't. Oh. Awesome. How's that one going? Excellent. Okay, and then we see a lot of BI tools coming up now as well, right? And here you can go a step further. You can start mining into the data a little more. However, there's limitations there too in terms of driving action. And some of this comes out of the complications with using those tools and the specific kind of knowledge you have there. But again, there's a kind of disconnect between the actual modeling data science piece and then what's actually coming up in the tool. And so how we're seeing companies, the kind of leaders, solve these problems and not let insights go somewhere to die is they're actually incorporating them to data-driven applications that live in the cloud, right? And really the easiest way to kind of give an example of what I'm talking about here is actually to kind of revisit the use case that Noelle was talking about. And so here we're talking about ratings prediction, and we went through the process of building the model, and now we have some quantifiable impact of these levers or these production decisions on ratings, right? And so we incorporated this into an application as the one you see here on the slide, and a couple of graphs going across the top, and what these are representing is what is the ratings at any point of time within the show. And so we're looking at a news broadcast here, or a talk show. And so one of the production decisions they had was, who's on screen at any point in time, right? And so if you think about that, well, there's certain people, but they come with some characteristics behind them, right? And so in this case, we have an example of political affiliation and what kind of job role they had. And so those were some of the features that actually popped up in this model here, right? Was how long someone's on screen and then what's their kind of characteristics. And so what we were able to do is incorporate those findings into a cloud-based application, which then allowed end users to say, wow, this is an interesting insight, right? On-screen arguments make people tune out, or a certain kind of political affiliation talking about a certain subject makes people tune in or out. But now they're able to go in there and say, well, that's interesting, but now I want to take some action. So maybe I can toggle some of these levers and some of these decisions and see how it impacts ratings. Maybe I need to have someone on the show to talk about a topic. And we know viewers may tune out or in because of that. So let's kind of balance that out, right? And so this example here, we can see some of the toggles, and we're able to go through things, and basically anything that turned up into the model itself was exposed to the end user through these various dials that they could toggle around. So this is an example here of incorporating kind of data science into an application to drive kind of action, right? Which is the production decisions. But it's not enough to just say, hey, this is an interesting insight, right? And there's some characteristics that we've identified which really make an insight actionable or valuable to a business. So the first of those is it needs to be accessible, right? So yeah, again, right, we can send off an email or a PowerPoint with an insight in it, but it might die there, right? How many times have you had something pulled up on your desktop, you go into a meeting, and now all of a sudden, hey, I don't have access to that information anymore. It'd be great to have that also on an iPad or on your phone that you can pull up or in the meeting. That's a simple example, but it gets very complicated, right, where we think VPN logins and so forth that you have to deal with. And so, for us, we see that, well, really for an insight to be powerful, you need to have access to a quick access, right? The second here is kind of social, right? You need to be able to socialize insights within a business for them to be actionable. So a good example of this is many times you say, hey, revenue, the definition of revenue is this, and 8 different departments have their own definition, right? And that's because those insights aren't getting socialized and people aren't agreeing on what the insight actually is. The next, it needs to be scalable, right? So a one-off insight that you drop into an email isn't enough, right? Because the next person might say, hey, I've got another question about that. All of a sudden, it's back and forth, and it blows up into 100 emails that you can't make sense of, right? So we need to keep that in mind. We need to be able to iterate on it and make it expand in a way that makes sense, right? The next is it needs to be open, right? So we need to be able to look at an insight and say, how did the data scientist or analyst drive this insight and what made up that value or that insight, right? And you need to be able to go in there and kind of understand the workings of it. Obviously, it needs to be relevant to the business and the problem at hand. And then finally, it needs to be real time, right? If I have an interesting insight, if I don't take action on that straight away, over time, the power is diminishing the value, right? So why cloud-based applications then? Well, really, cloud enables a lot of the characteristics of actionable insights, right? So media companies are traditionally not in the business of building out scalable infrastructures, right? So we see things like service failure and data loss at scale. Once you get an application pushed out on an infrastructure that's not built for scale, right? And things happen where it's all of a sudden these insights are no longer powerful, right? Because I can't get access to them because the system is down. We also see things like long innovation cycles. So, hey, this insight's great, but I saw a little bug here. Well, it's going to take 2 or 3 months turnaround for me to fix that, right? That's no good because we're not hitting the real-time aspect and it's no longer actionable at that point. And then finally, right, we don't want just one person logging into the system. We want to be able to scale it and have everyone in the business having access to those insights in that application. So, companies like Google, Pivotal, where we work, we've spent a lot of time kind of solving these problems, right? Building out the infrastructure so that, media companies can focus on what they're good at, right? And so using these kind of platform as a service, you're able to kind of deploy the applications that are specific to your business, and it allows you to basically solve for all these issues that we saw within kind of internal systems. So now they're kind of resilient, we can scale them out. Agile, right? Find a bug, we have now week, day, sometimes even shorter release cycles. And there's also low latency at that point, right? We're able to take advantage of a lot more powerful hardware systems in this kind of shared cloud environment. So there's a lot of kind of pieces that come together to make these happen, right? Framework that kind of extends through lots of different working parts. And really it takes a lot of kind of tools to make that happen. So I'm going to pass over to Watson now, and he'll give an introduction to some of these tools that we're using.
Sure. Thanks, Jared. So like Noelle and Jared mentioned earlier, one of the characteristics of good insights is it should be open. And our talk is about how do you deploy data science models for media using open source toolkits. Now, the reason why open source matters is because you don't want vendor lock-in. So let's say today you build a model, you want to be able to change it and port it perhaps to a different platform, if your economics don't dictate that you continue with what you have today. Likewise, you also want the ability to be able to extend the model by understanding the inner workings of the code which goes behind a data science model that someone built for you. So for a lot of these reasons, open source tools are preferable, and we see this amongst a lot of our own customers at Pivotal as well. Now, our team in particular, we make extensive use of open source tools, and some of those tools are, as you see on the screen. So there are tools which we use for building models. So these are algorithmic tools. For this, if you ask any data scientists what are the favorite tools that you may use, they might say we like to use languages like R and Python and the ecosystem of libraries which comes in these languages. And we particularly use a lot of Python libraries like scikit-learn. We use GenSim, we use NumPy, SkyPy, so on and so forth. We use a lot of R libraries. So the CRAN-R repository, for instance, has several thousand libraries for statistical machine learning, and we make extensive use of that. We have our own open source library called MADlib, which contains implementations of almost 33 different machine learning algorithms which are widely used in the field. And these are implemented in database so that it scales really well without moving a lot of data around. You push the computation to where the data is. And then, of course, there are other open source players like GraphLab. There's the Apache Spark project, for example. And they are more suited for real-time use cases, and we also tap into that extensively. Now, the way we scale these algorithms in our open source tools is by taking the Python, the R ecosystem of libraries, and using procedural extensions to SQL like PLR, PL Python, PL Java, so on, so that we can immediately get scalability, for data parallel problems. And for truly parallel problems, libraries like MADlib, Sparks, MLlib, cater to our needs. For visualization, there are two aspects. So first off, if you're building an app, that app primarily is consumed by some sort of business analyst or the business. Now, there's another component where Noelle touched upon this, and Jared also touched upon this, that you want your models to be something you can socialize. So often in a large organization, you'll have a lot of business units, and in order to get maximal impact, you have to convince other business units of the utility and value of your models. For that, you need data science storytelling, and this is something we do all the time to our customers. Once we build a model, we want to be able to communicate what the model does, and we also want to convince the customers that they can tweak these models in an easy way. And we use toolkits like IPython notebooks and the Project Jupyter, which sort of unifies things like IPython notebook for other languages. So these are very effective in that you can build a living document which contains both code as well as insights, which you can hand off to your own internal units within the organization so that they can tweak the code and really understand the model. As far as visualization for apps themselves go, we make use of libraries like d3.js. We make extensive use of pandas, some of the Python plotting libraries like MATPLOTLib, and in the R side of the world, we make use of ggplot, and things like Gephi, Bokeh, so on and so forth. Now, what does this open source ecosystem consist of? What components form this open source ecosystem for building data science models? We've all the while been speaking about, apps are vital for your business. So if you want to do, data science, you want to be able to convey the results of the data science through apps. Now, apps are driven by analytics, and analytics consumes data. So the more data you have in terms of quality and quantity, the better insights you can come up with, and that can be ultimately conveyed through apps. So this virtual cycle that you see on the right can be directly mapped onto this open source scalable platform that you see on the left. And the platform that we've encountered a lot and we make use of a lot for a lot of our media use cases for data science is Hadoop. So Hadoop forms the data layer of this open source scalable platform because it's built to run on commodity hardware. It helps you focus on the problem rather than worrying about stability of the platform, scalability, so on. But Hadoop alone is not going to cut it out for you. And if you ask any data scientist, what is their favorite paradigm of writing data science models, they're not going to say MapReduce is my favorite paradigm for building data science models. A lot of them will say, I like Python, I like R, I like Scala, and all the libraries which come with those languages. So we think that, we call this the Hadoop++ ecosystem. So these are tools which work with Hadoop at the core, but these are tools which include things like SQL engine on top of Hadoop. Now, for example, you have Hive, which is sort of like a SQL-ish engine on top of Hadoop. We recently announced this Open Data Platform, which is a collection of open source SQL on Hadoop tools, including Hawk. So it's a fully compliant SQL engine. And there are other moving parts to this open source ecosystem. For example, you need something which can act as a message queue. So for that, we have RabbitMQ. And for deployment of cloud apps, we have things like CloudFoundry. Again, these are all open source tools, but they ultimately form the Hadoop++ ecosystem, which supports data science for media and for other industries as well. Here's an example of one such pipeline for building data science models. And if you can recollect what was on the previous slide, we've mapped some of that onto this pipeline. Now, first off, before you start building data science models, you need data, and data comes in multiple flavors. And if you've heard of 3 V's of big data, volume, velocity, and variety. So big data comes in all flavors. So you have structured data and unstructured data, and the data has to be ingested in different frequencies depending on the nature of the data. For things which are more real time, for example, social media feeds are pretty real time. That would be real time ingestion. Then there are things which are near real time but not quite. Perhaps you have a set-top box which is aggregating data every 15 minutes and beaming it up every day or perhaps a couple of times a day. So that's sort of like a micro batch scenario. And then there is data which you could collect from Nielsen, for instance. Maybe you can get a weekly dump of data about ratings for different programs. That's your typical batch ingestion, right? So these different frequencies of ingestion should be supported by your open source framework. And Spring XD is one such tool, which is open source, allows you to ingest data into your environment at different frequencies. Now, once data gets into your Hadoop++ ecosystem, all model building can be done with the libraries and the languages that I just listed, things like R, Python, through procedural extensions of those specific languages in SQL. You can use Spark, MADlib, and ultimately derive insights, which can be communicated on dashboards. Now, remember those 3 different velocities of ingestion that I spoke of, real-time ingestion, micro-batch, and batch ingestion. So in the next couple of slides, we're going to speak to some example use cases where we worked with real media companies which fall under these different ingestion velocities. So here's an example of a ratings prediction application, right? So here you want to predict for a couple of shows what are the ratings of the users, and you want to be able to identify what levers can you vary to impact the rating. Now, the data for this can be ingested into a data lake, and in this scenario, it could be data from Nielsen, right? So it could be something which you get on a weekly basis or a monthly basis. So it's sort of a batch example. Once data has been ingested into your data lake, you can use a SQL on Hadoop open source querying engine, using which you can query the data and start building models using Spark, MADlib, Python, what have you. Once you've built models, you want to predict ratings on previously unseen data, right? Just so that you understand the impact. Now, those predictions could be altered using business levers, like what are things you have control over, what are things you don't have control over. Perhaps you have control over how many ad segments you can run in between a show. Perhaps you don't have control over how long those ad segments could be. So those are business levers which alter the predictions, or perhaps place constraints on how your model can perform. And ultimately, you build a dashboard, which Noelle and Jared, both of them explain, which shows what if scenario analysis. If you were to change the value of one particular lever, what does it mean in terms of the ratings prediction or the variance of the ratings itself? Now, this application itself can be deployed on a platform as a service. CloudFoundry is one instance. You could deploy it on Amazon Web Services or any of the other open source platform as a service solutions which are available. Here's an example of a micro batch ingestion use case. So previously we saw that we can take Nielsen's data, we can predict ratings for different programs using the open source framework. Now, what if you had data which is more real time? Here's one example, right? So if you wanted to, for instance, determine what is the optimal number of times you have to show an ad to a user to increase the impact of the ad. Studies have shown that if you show an ad to a person more than 4 times in a given day, the person may not even remember that ad, and you're wasting those impressions. Now, if you want to do that kind of analysis, you need an extension of the framework we just presented, and here's one instantiation of it. So you may want to gather video ad impression statistics, and that information can be submitted to a message queue, such as RabbitMQ, again, open source. And then SpringXD is, the one tool perhaps which has several use cases. And that could help you ingest this data into a data lake. You do the same thing of, using a SQL on Hadoop querying engine to query that data lake, build models, and you want to simulate the ad server logic, right? So the goal here is to look at historical impressions data of what ads you showed, what users, how many times on what given day, and you want to simulate the ad server. And the simulation levers are basically things like, what if I put some constraints that I want ad to be shown no more than 3 times for a given user on a given day, or perhaps I want to show it only 5 times in a given week. What does that translate to in terms of revenues? So at the end of my advertising cycle, will I be left with surplus impressions? Will I be, would I not have delivered all the impressions that I promised to my advertisers? Now, those kinds of business levers can be plugged into this ad server simulation logic and visualized in terms of a dashboard, again, which is on the cloud. And the dashboard could tell you things like, at the end of your advertising season, do you leave things on the table by admitting to a cap on the number of times a user can see an ad? You perhaps are interested in, things like what would be the amount of money I might lose by accepting to these terms and conditions from my advertisers. So those are things which you could do with this framework. Now, the third of those different ingestion frequencies was more real time, right? Now here a classic example is if you wanted to measure audience engagement. Now this is something which a lot of media companies do, a lot of them are interested in doing, and social media data has been changing the whole game for many of these players, right? So you have providers like GNIP, which is an aggregated provider of social media feeds. It got acquired by Twitter, so you can get a decahose from Twitter, for instance. So that's 10% of all the tweets which were generated on any given day. That gets beamed to you in a live stream. Now, this kind of a real-time stream is about 55 million tweets a day, several million in an hour. That, again, can be ingested into your data lake. And here you want to build models to understand audience engagement, right? Things like, what are the topics of conversation? So, for instance, if you have the Oscar program going on, you want to know if the audience are really liking the hosts. What are the topics of conversation? Are they talking about, the host's attire or their manner of introducing, the winners? Those are things that you could do from social media data, and this is real time. You can do topic analysis, you can do sentiment analysis, and sentiment analysis could be really useful when you view it as a time series, for instance. This might be useful if you want to see if, whether a new guest, when they were introduced, who, came to the stage and, got an award, did that get viewed positively by the audience? Was there an increase in sentiment? Was there a decrease in sentiment? And this sort of a dashboard will give you immediate feedback. You don't have to wait for analysis to come back, the next day to summarize the whole event. So these sort of different scenarios where you have different ingestion frequencies can all be supported by the open source framework that we are describing. And with that, I would like to hand it over to Noelle to summarize some of the key takeaways of the open source framework we've presented.
Thank you, Watson. All right, so I know that we just walked you through a lot of different things, but so what are the takeaways that we want you to have coming from this? So first, again, so when you're trying to establish a framework and up your data science practice, always, as we said, start with the data. The more that you can blend your data sets with what you have internally, with external data sets or even the unstructured data sets that you didn't consider before, leads ultimately to richer models and more valuable insights. Right? Don't leave any data stone unturned, really. Again, so and then aside from those models, make sure that those see the light of day. Make sure that you actually turn those into something valuable for the business by putting them into data-driven applications. Put it in the hands of the decision makers. Don't just let it die with the data scientists or your researchers. This whole talk we described a lot of open source tools. And obviously we're big fans of open source tools for many reasons. Obviously one is that it's free, that people enjoy, but there's also lots of things in terms of flexibility. Because if you support open source, there's not one tool that fits everything. So you actually have a flexibility to pick something that will either fit with the skill sets of the people you have in-house or the innovation that's coming across the industry. And there's a lot of power in those things as well. The most powerful tools we've seen actually do come from the open source community and isn't locked up in some proprietary tool. The platform itself should support all of these things. Like when your platform is extensible and can support all these open source tools, including the variety of things that come up with data science, that's kind of key, really, for us as data scientists. And the last takeaway that we had was that, as Jared had pointed out, that using a PaaS service takes away a lot of the headache of infrastructure. Right? So understanding monitoring, server configuration, scalability, all of those things are taken care of. Right? So focus really on the problems that you have at hand and really and leverage the power of some of these tools. So with that, I want to say thank you for your time. Thanks for having us today, and let us know if you have any questions.